Chris, with that, I'd like you to take it away and welcome everybody, and Q&As in the Q&A section. Thanks, Chris.
Brad, thank you, and thanks for the introduction. Actually, Brad, one keynote here, there was an autonomous question, which is perhaps you can announce how the attendees can further access the recording after this brief webinar.
Yes, Chris, what we'll have is they will receive an email that will give the link to this recording afterwards.
Great.
Okay.
Thank you, Brad. Okay, thanks all. As mentioned, my name is Chris Olson, been a global knowledge instructor here since 1999, Cisco instructor since 97, in IT full-time since 1993, throughout these different areas of networking, security, data center, and collaboration. All right, so our topic here is all about campus layer security. So let's start off with a good question, and that is, where is a good place to put security in the network? Well, I'll ask that as a rhetorical question. Let's go back in time. How did we used to do this back in the 90s or so forth? The answer would be, if we have a connection off to the internet, I'll just add that simply here, and somewhere along the way, there would be a typical connection. Let's do it good and fault tolerant, and somewhere there would typically be a firewall. Okay, so for all internet-facing connection, having a firewall, of course, makes good sense. All right, fast forward. What's the best place in today's world to have network security? The simple answer is everywhere, but always as close to the source as possible. For example, let's say there was a computer off of here, and this computer was, let's say, breached. It has a virus, it has denial of service attack software on it, it has something very undesirable. So if the firewall was the first line of defense, but yet the computer's already in the network, notice the fact that virus or the hacker or the criminal or anyone trying to steal information, they can start wandering through the network until they hit something that's going to stop them. So notice that all these devices down below here are potential devices to access in. We're not even using the firewall. So while the firewalls for internet facing, of course, makes good sense, of course, everyone does that, we're making no statement to apply otherwise. Question about what about all the other devices down below here? Okay, that's our key topic, is how to make them more secure. So where's the best place to put security in a data network? Current answer is everywhere, but always starting as close to the source as possible. If somebody walks in with an iPhone, as close to the source as possible is where they connect in, the wireless access point. If someone has an individual laptop or a computer or a tablet, as close to the source as possible would be right where they connect in. So that's our focus, how to lock that down and make it more secure. Going back in time, a little IT trivia question, who invented Ethernet? The answer was a man named Robert Metcalfe, which goes back to 1973. So Ethernet switches, like we're showing here, always had the original goal from many decades ago of just connect. Here's another way of looking at security and networking. There's two top-level objectives: connect and isolate. Back in the history of Ethernet, its original goal was only to connect. So if we want to get to our web server, of course, we have to connect to it. Obviously, we better have connectivity. Of course, want to get our email, we better have access to the email server. Okay, that's obvious. But it's important to note that if everything can connect to anything, networking might look easy, security is terrible. Full connectivity is terrible for security. How does a hacker hack in to any network? Because they have secure access. They can connect in. How does a virus spread? Because of connectivity. How does a denial of service attack cause problems? Only because they can connect. How does someone steal hospital medical records illegally? They had to connect somehow, somewhere. What if they can't connect? So the goal is, let the good guys in, keep the bad guys out. Allow connectivity for everything needed for production, but everything else should ideally be isolated. And where's the best place to start? The first place we connect in. That gives the highest level of security for everything we're going to do on the network. So a couple years back, the organization called the IEEE, Institute of Electrical and Electronic Engineers, created a standard known as 802.1x. It's a protocol that allows for secure access when we first connect in. 802.1x is the first line of defense. It goes right where end node devices, whatever they may be, first connect in. So 802.1x is not a protocol in the core of a network, like the backbone of the internet does nothing with 802.1x. A core of a data network, nothing to do with 802.1x. Where we connect from the internet into our network, if allowed through the firewall, again, not 802.1x. But for wired or wireless connections, here we're showing wired, but for wireless as well, 802.1x provides a wide variation of security as we connect in. So there's a couple names of pieces of the puzzle in this protocol. First is the idea of a supplicant. The word supplicant comes from the word supplicate, which means to beg or to give in. It's kind of like a medieval word where hundreds of years ago, the poor peasants would supplicate to the owners of the castle, and they would ask for something. May I please have something? Well, in today's world, the IEEE has used that word meaning a supplicant has software on a computer like an iPhone, a tablet, a laptop, a computer, and this software supports 802.1x. So how does the supplicant get in the computer? And again, its purpose is to ask for access. Again, traditionally, this device here, where we would first connect in, and again, there could easily be, and more likely is a Ethernet switch here, there could be a wireless access point. All that is what we could supplicate to. But supplicate will mean, may I please enter the network? And our 802.1x network will initially say no. But if you give us the right credentials, then we'll open up the door. So think of 802.1x as saying we went from infinite unsecurity to total lockdown security, where the first access is denied. 802.1x has the ability to do that. So the catch is it has to be supported in both devices. 802.1x must be in the laptop, in Windows 10, in the iPhone, in the iPad. So how does it get there? Two key answers. One of which is it can be what's called a native supplicant. A native supplicant. A native supplicant means the creator of the operating system put the software right in there, right? So Microsoft Windows 10 has a native supplicant built in. How do you get it there? You buy a laptop, you get a computer, you install Windows 10, it has 802.1x built right in. That's said to be a native supplicant. No installation is needed if you want to use the native supplicant. Okay, if we go back way back in time, 20 years ago, like Windows 2000 Professional, which would have been the equivalent for Windows 10 in today's world on a desktop. Okay, that was before the time here, and so it did not have that at that point. So it did not have that software 802.1x in there before, but again, most all products in the last 5 or 10 years have a native supplicant. In addition, Cisco has created a supplicant to give full 802.1x support and a lot of other security features. And it's called Cisco AnyConnect. So AnyConnect is the Cisco current answer for a 802.1x supplicant. There used to be prior products in yesteryear, but the key focus now is on AnyConnect. So AnyConnect is a free download, and AnyConnect can connect in any way. The word any actually has technical meaning. I could connect in with wired, wireless, or a VPN connection. All of those are being represented by what we show right over here. So where does 802.1x live in this example? Right over here for our devices connected in. Next is 802.1x is expecting, like any security protocol, usernames and a password. So where are the usernames and passwords kept? This concept is called an identity store. The word identity store means a location where the users and passwords are kept. Can you put them on a Cisco router or switch? The answer is yes. But in a large environment, that would be very poor and unscalable, because if we had 500 access switches and we have thousands of users, then I'd have to put all the usernames on all the switches or routers at the same time. And a new user gets hired, you got to go to all the routers and switches and put them on there. A user leaves the organization, we have to go to all the switches and take user Joe whatever off there. Okay, so that doesn't scale. So a better approach is to use a protocol called Radius to an authentication server. Radius actually dates back to the days of dialing up with a modem. In fact, that's in the acronym, Remote Access Dial In User Service. If you were in the 1990s and you were in a hotel and you wanted to get on the internet, the way back then was we take a modem on our computer and we plug the cable into the phone jack in the motel room and dial up, and there would be some Radius server we connect to. All right, so fast forward, we're doing no modems anymore today, nor do we need to. The protocol, however, has kept the same function. So Radius, while it was designed in the days of very low bandwidth modems, is in no way restricted or limiting our higher bandwidth network today. So Radius lives right here. So the idea is this device, often called a network access device, or the Radius authenticator, which could be a router or a switch or a wireless access point, is going to let us connect in with 802.1x here, and then this device will ask the server, can I connect in? So the idea is the Radius server is the next option of where the identity store can be. This product in Cisco, if we date back to the 1990s, used to be Cisco Secure ACS. That was the older name. Cisco Secure ACS. Cisco Secure Access Control Service. Okay, from the late 90s till just a few years ago, that was the way someone would buy a Cisco product for Radius. Then ISE came along several years back, and ISE is now fully superset. So the identity service engine in Cisco is now the full superset for that. I see a question here. What's the difference between a NAD and a NAC? Main answer is, in our industry, we often have too many acronyms for the same thing, or depending on the organization, the standard, or the company product, two names for the same thing. So Seraphin, good question, but the simple answer is they're the same thing. So the initial device we connect in is sometimes called the network access device, where we originally connect in with 802.1x, and it could also be called the NAS. And then from there, it is Radius that talks over the network to, again, what would now be the ISE server. Benefit, I've worked with some organizations that literally have 1 million EndNote devices here. I mean, not 800,000, we're talking literally 1 million. A very large example, chain of hospitals and clinics with medical equipment, Internet of Things, laptops, tablets, right? All those things are connected in, and what they've chosen to use to connect 1 million devices in is a group of ISE servers. Now, one ISE server would not be appropriate for that, so we could have several ISE servers in a fault-tolerant arrangement. So here's another way of looking at it. Here's our devices that want to connect in. Where would security do the best job? As soon as they connect in first on the network. This example shows a Catalyst 9000. Side note, Cisco has put the most amount of security features, bells and whistles, functionality in the Catalyst 9000 switch. The 9000 refers to the newer model in Catalyst. Side note, don't confuse this with Nexus 9000, that's a different product, or MDS 9000 or ASR 9000, these are different Cisco products, but what they share in common is the word 9 in the number means newer or latest, more recent features. So This is just one example of that. And we're showing just wired here. Of course, we could be wireless. We could be wireless as well. All right. So next is all these devices, when they first connect in, if they're going to do anything wrong with the network, we should know, like right here, as soon as the close source as possible. So 802.1x, when configured here, will actually logically shut down the interfaces. It's not doing a manual shutdown. It's not like a spanning tree blocking a port, but very analogous to either, where 802.1x would not enable it by default, except if a user wants to connect in, their traffic would be allowed, and then this device would then talk to our ISE servers. This over here could be any group of network devices. This could be 1,000 miles away. It could be in a different city. It could be from a campus to the data center. Could be a bunch of routers. There might be firewalls in here. All that is fine as long as radius is allowed to configure between these two. A side note comment, you may have heard of the protocol TACAX. ISE can do both. Here's the key difference. Radius is for our end node user devices to get through the device into the network. And somewhere over here would be all the rest of the network. The data center, the WAN connection, other computers we need to do, perhaps off to the internet, whatever it may be, would be all off here. Radius gets us through there, whereas TACAX is for network administrators if we want to go to the device to be a router, switch, firewall administrator. Again, ISE can do both, one, the other, both. Our focus this discussion is radius, which is going through it. So radius would be configured from here to our ISE servers. This example shows two different ISE servers. When you start to spread out the load, fault tolerance, these servers here would be what's called a PSN, Policy Service Node. When you configure ISE, you check a few boxes on the server that gives the role of Policy Service Node that allows that communication between radius and our TACAX to all of our devices. Again, there could be hundreds or thousands of these devices. Wireless access point, VPN concentrator, access switches. Throughout the campus, they could be located anywhere, and all of which can be centralized with ISE. So where's our user store? Where are the users kept? The answer is wherever you want them to be. You could keep them in the devices mentioned here. That doesn't scale well at all. You could have them in ISE. Or we could use an external identity source. This is very common for very large environments where Microsoft Active Directory or LDAP or an external database could contain the usernames and passwords. So the flow would be like this. I sit down on my computer, I start up, I want to connect in the network. My 802.1x supplicant, whether native or AnyConnect, will ask the question, hey, may I join the network? I'm begging to join, I'm supplicating. This device will say, one moment, let me talk to ISE. ISE will say, okay, I see the request. Let me see if the username is valid. Check that, yep, it is. Do we have the right password? Yes, we do. Okay, now I'll let you in the doorway. Now to take that further, ISE can even further lock down the switch to even create access lists to say you can go this way to our WAN connection, but not this way to the data center, or vice versa, depending on how we define the configuration on that. So again, the network access device, our first line of defense, 802.1x, radius, are a team, and they work together to allow us to control where we're going to connect in. Okay, so ISE itself, the identity service engine, again, has fully replaced Cisco Secure AnyConnect. If you happen to use AnyConnect as mentioned in years past, that has gone end of life. So it is no longer a product that is sold or supported by Cisco, but ISE is front and center on this. So ISE again scales literally to millions of devices that could connect in for sure. So one of the things ISE does is it's a server, and this server can be either a virtual machine or as a physical appliance, or several virtual machines, or several physical appliances. You can download ISE from Cisco with an OVA file as an example, Open Virtual Machine Appliance. When you download the file, we can install this on VMware. So for a smaller environment or lab or testing, a virtual machine has a benefit of, doesn't need to pay for any hardware other than the server hardware that you likely already have. Okay, then if we have multiple ISE servers, they will all synchronize and talk with each other. So downloading this OVA file is all inclusive. Everything is all in this one file. Open Virtual Machine Appliance gives all the features and technologies of ISE inside there. So I'm a user, I want to connect in. Next point, what's the best way to implement security? Know nothing of what's going on, or know as much as possible of what's going on, right? Lack of knowledge is unsecure. How can you secure something you know nothing about? So ISE has the job of being very well aware of everything that happens. So I connect in here and I'm on a wired network. So I'd have my Cisco Secure AnyConnect and I would log in as a user. User who? So who is my username and password? What device am I on? So I could be on an iPad, I could be on an iPhone. How am I connecting in? Wired or wireless? When did I connect in? Thursday, 5 p.m. from my device, from the Catalyst switch that is located in our campus switch, second floor, campus network, second floor, whatever it may be. Okay, so all these things are initially what 802.1x does. Cisco AnyConnect can take that a step further with something called posturing. Posturing means compliance. Example, what if I have the right username and password here, but I've already have a virus on my laptop and I walked right in, I sat down in the conference room. Okay, goal, we should never do that. Question, what if it happens? The username and password, 802.1x cannot fully detect that, but posturing can. So ISE can actually look at and identify the device and say, you better have anti-malware software, antivirus software, anti-spyware software, whatever you and I, the ISE administrators, require. And after 802.1x authenticates, then we could verify that that software is present. Cisco does not create or in the business of creating antivirus, but works with all third-party companies to allow that to be verified on the end node device. And you might say, well, the likelihood of getting a virus on an iPad is less than a Windows 10 machine. That might be a fair assessment. If you agree with that or like it, you can make policies that say, I'm going to have the posturing more strict on the laptop and perhaps less strict on the iPad. And what if we have a printer? We might make it less strict as well, as the likelihood of getting a virus of a printer is always possible, but significantly less. So on this, ISE remains the brain. It's the main place where we control all the connections of everything coming in. In addition, ISE can work with other vendor products, right? So if we have some mobile device products, we could have a mobile device manager, third-party products that could work with ISE. So when our mobile devices connect in, ISE remains the master brain, checks in. So a fair question, how would ISE connect with other products? Well, like in the world of programming, there's often something called an API, Application Programming Interface. Analogy, a software programmer creates two software programs. They want the two to work together. How do they make software program A easily work with, share information, look up information in software program B? Software programmers for quite some time have created Application Programming Interface, a way for two or more programs to talk. ISE supports several APIs. The one here is something Cisco helped create for the industry called PX Grid. PX Grid, Cisco started as an API, and the idea is share secure information of the context relative to our users connecting in. Context, all of this can be shared with products that can add to the security. Worded another way, what's the best way to secure, let's say, a house? Let's say we got a pot of gold, don't I wish, sitting in a safe in our home. What's the best way to secure it? Answer, defense in depth. Multiple layers of security, better than one layer of security. So if there was gold in a safe, well, we'd lock the safe, of course. We'd have the safe in a room, we could lock the room. Good idea. Then the outdoor doors of the house, we'd lock those as well. Gates around the house, we could lock those. So bad guys wants to steal what's in the safe, got to first get through the gate, then the house, then the room, then the safe. That's defense in depth. The best form of security is multiple layers fitting together. That's what PX Grid does. And the center of PX Grid is ISE, Identity Service Engine. It's the center point that's keeping track of connecting to all kinds of other products to ensure that all that they can offer with added security is now centralized in ISE. Okay, these products are not required, but the idea is they could be linked together. Side note, Cisco Secure ACS, it could not do anything in PX Grid or posturing. It was a good TACAC server for the years, but doesn't have nearly enough security features for all the security vulnerabilities that could happen. I mean, this device here could be someone walking in a conference room with a laptop, an iPad. What if it has some software or anything that is unauthorized or could cause a problem in the network? What's the best place to stop it? Right at the source. And that's again what posturing does. Okay, so these guys work together where ISE is the authentication server. And again, the identity store could be an Active Directory, but doesn't need to be. Could be an LDAP or a second database, but they could be an ISE as well. And the idea here is ISE is going to work with the NAD with a radius right here and 802.1x down below here. All right, a little IT history trivia question. Where did the IEEE come up with the number 802? The answer was Ethernet got invented in the 1970s at Xerox Corporation. The copy machine company actually invented Xerox. That's where the local area network got invented. Well, in February 1980, literally that month and year, the IEEE got together and said, let's create a standard for local area networks and later wireless networks and secure access like we're seeing here. So literally that standard name means is an open standard, but came from back in the days of February 1980, and they weren't feeling terribly creative that day, so they just named it after the month and the year. And 41 years later, it stayed the same way. .1x is simply the name of the standard for connecting in. See a question here. When getting the OVA, how long does that last for? Would that only be for a lab? Okay, so the answer is downloading an OVA for Cisco, the actual file of the OVA lasts forever. It is not time bombed. It is not limited. So if you have a Cisco CCO account with a valid access, you can download the OVA and keep the file forever. It never times out. You use it to install ISE. However, the second part of the answer is when ISE is installed, you get a grace period. So for lab and practicing, you could do that. But for production, when the time comes, you pay Cisco for the license. So it isn't the OVA that needs the license file. It's the result of the OVA, which is ISE, that does have to be licensed. Worded another way, 20 years ago, how did we license with Cisco? We'd raise our hand and say, I want to be a good boy, and I'm good boy or girl, and I'm doing the right thing. Okay, fast forward today. Thanks for raising your hand. Please prove that you have the license. So you do have to license ISE itself. So it's not the OVA that needs it, it's the license itself. How can you implement Cisco AnyConnect and ISE in the same network? For sure. What you do is go to Windows and install AnyConnect here. As soon as you do that, AnyConnect has full 802.1x built right in. So you download Cisco AnyConnect free software, install it on a end node device, and then AnyConnect, when you connect in, whether wired or wireless, will work directly with the network access device. So this NAD is a Cisco device that would need configurations enabling both 802.1x and Radius. So it has to be configured with both of these. Both of the configurations have to be there. And the end result is then AnyConnect will work directly with it. Cisco AnyConnect has full support of 802.1x built in. Let's take that same question further. What if I have a printer and I want to do some security with the printer, but, well, it's a printer. So how do you load a piece of software you download on a Hewlett-Packard printer or a Canon printer, whatever you have? You don't do that, of course. Printers are not designed to allow for added software. What about a camera or a video surveillance unit? How do you load software in those units? Well, you don't. You can't. So AnyConnect just won't work for those. That ends that discussion. AnyConnect is where you have an operating system that allows you to install some products. Windows, Linux, Apple products. Unix would be the most common examples. A printer, phone, video camera, they have no way to load software, but they're on Ethernet. So an alternate to 802.1x is MAC authentication bypass. Here is the lowest level security, but it's, well, better than zero security. Just a little better than zero. Because in MAB, all we do is say the MAC address of the device, we're going to manually add in ISE. So that's a lot of administrative work. Goal, we don't want to use MAB, but what if you can't install 802.1x software on a device? Then MAB is an acceptable alternate. That's why it exists as an option. So we could also say inside this device, first thing, we want to look at 802.1x. And if you have the supplicant, we're going to look at that and enable, make sure your security is enabled and let you in. And if we connect over here and we don't have a supplicant, we can then say, well, let's try option number 2. So the username and the password literally become the MAC address, which again, all Ethernet devices always have. Every Ethernet device has a MAC address. So this authentication method is a little bit less or greater than nothing, but not nothing, because at least the MAC address would be known inside ISE here as well. Okay, if we want to take that even further, after we authenticate and we know who you are, we can make policies in ISE to say, if you are a guest connecting in, you're not employed at our organization, we'll let you connect in, and when you do, ISE will automatically configure this NAD device and put you in a VLAN automatically as you log in. And that VLAN 10 or whatever might only connect to a router that goes off to the internet. So our guests, you get internet access, but we don't want you getting to our data center. You're not authorized for that, let's say. Or you might say, when I connect in as a contractor, I could make a policy in ISE that would literally go right inside here and create an access control list just for this device. On the fly. ISE is an automatic real-time network reconfiguration device. That's my wording, but it's exactly what it's doing. And once that's done, now if I connect in here, that ACL might let us through the internet to other campus networks, but not to the data center or wherever else we want to do. We can do anything you've ever done with an access list or an AC or a VLAN. ISE can do that all automatically. Again, that's the power of these teams working together. 802.1x here, Radius here, with ISE allowing us to control the configuration. Which brings the question, what's the protocol and mechanism for ISE to configure this device with a VLAN or access control list? Okay, and the answer is inside Radius, there's a field built in called a type length value. TLV is a common feature in networking where there's a couple headers that the architects of the protocol put in the protocol, like radius, to allow a future generation to be able to add a feature in it. In better words, we don't know all the features coming, so let's allow for that flexibility. Well, that's called a TLV. And what Cisco did with ISE is allowed for VLAN or access control administration. So when you connect in here, we're not only letting you in the first door, but we're opening or shutting any other doors. This concept could be taken one further step with something called TrustSec. ISE also is the center of TrustSec. TrustSec would still have 802.1x connected in here, no difference there, to our network access device or NAS, same thing there. And if we have the right username and password, then all the data packets from this user can be tagged with a field inside the frame called a SGT, security group. Sorry, it's a lousy T there. Lousy G, security group tag. ISE will tag the frames. Later, this frame will go to another router, and the router will say, one moment, I see your tag only allows you to connect out this interface, but not this one to our data center. So every router can then can be involved in allowing or not allowing. That's called TrustSec, and in Cisco, ISE is the master brain of that. ISE is the centerpiece of it. Okay, finally, in ISE itself does have to have every individual device added to it. So if there are 50 switches as network access devices, we have to manually add them in. Pretty easy to do, like we see here, but again, they have to be added. So if ISE doesn't know about a switch, you got no radius of the switch, and there's no centralized identity store, and the switch is on its own in securing access. But as soon as ISE knows about the device, then all the policies can be configured inside of it. All right, folks. Team, any questions, comments? I've seen a bunch, but happy to take any.
Thanks, Chris. Yeah, Chris, we got a couple that are here. I guess Dylan is asking for the OVA. Do you know what the grace period is? Is that a 30-day?
Yep. So downloading the Open Virtual Machine Appliance, the OVA file, the file itself has infinite time. It's just an installation file. So you can download that forever. It's not a fake or simulated ISE. It's always the real thing. You will have to have the proper contracts in your CCO account on cisco.com to allow you to start to download. So if you try and download the OVA file, it will deny you unless you have the contracts. Step two, if you have the contracts, you can download the file and then start installing ISE. And you can install it totally for free. But after a period of about 2 months, you have to install formal licensing in ISE. So again, ISE needs the licensing. The OVA has no licensing or time bound to it.
Okay, or else what they could do is maybe go to dcloud.cisco.com, see if there's any labs that they could play with there. The next one is from Bernard, and he was asking, does it work with AMP? And I'm assuming that would be ISE.
The answer is yes. And the idea there is AMP, or the Advanced Malware Protection, is another Cisco product that allows for additional malware detection in a cloud service, which can then be integrated with ISE. So that is a yes to that. Yeah, good question.
Okay, the last one I've got, Chris, is there's a question about NAD and NAC, and when it's related to the Cisco's new SASE environment. The only thing I can suggest, SASE is the Secure Access Service Edge. For those that
are
not familiar with it, they can go to cisco/go /SASE.
Yep, and for the most part, the network access device or the network access server typically are the same thing. It's our first line of defense. I'd like to apologize for our industry having too many names for the same things, but we're often guilty of that. This also can be called the authenticator. This could be called a radius client. It's the network access device. It's the network access server. We're saying the same thing here. ISE would be the radius server. ISE is also the identity service engine. So we do have more than one for the same thing. I see some other questions here. ISE works without TrustSec. Yes. So TrustSec is not required for ISE. It is an optional add-on. So ISE has the ability to talk with radius right here and 802.1x here. In this example, there's no TrustSec. ISE does not require TrustSec at all. TrustSec can be added to add to the security, but it's not required for base ISE functionality. On that same question, another Cisco software-defined networking product, Cisco DNA Center. DNA Center is a little play on words for deoxyribonucleic acid from biology, but it means the digital network architecture. This is Cisco's campus software-defined networking server. Okay, it is all based out of TrustSec and works directly with ISE with the API of PxGrid. So if you have DNA Center and ISE integrated with PxGrid, and you want to use DNA Center for intent-based networking, oh yes, you're doing TrustSec for sure. DNA Center will be configuring your network devices with TrustSec. It does so all automatically, but DNA Center is based out of TrustSec. ISE could use TrustSec, but again, doesn't have to be. When ISE is integrated with DNA Center, it's TrustSec for sure. Is there a separate license for TrustSec? Steve asks. So the official answer is not directly, but yes, indirectly. So there's 3 layers of licensing in ISE, depending on what you want to do. If you want the highest amount of features, there's the highest level of licensing called Apex, and there's a premium, and then there's a standard licensing. So depending on which features and functionalities you want, there are different licensing in production for those different features. But again, in a lab environment, your cost is 0. You could set it up on your own for, again, the first 60 days with full feature functionality in the absence of paying for any license. In production, of course, then ultimately we'd have to load a license file inside there. Is ISE configured in HA additional cost? No, the answer is no. So ISE itself, the licensing are based out of the features. So what makes this server different than this server? Well, all you do is download one OVA one time from Cisco, and each OVA will have the version associated. With that, then what you can do is from the OVA, install the first ISE server. From the same OVA, install the second ISE server. From the same OVA, install all the rest. So it's one download that can be used in VMware, in vCenter, to install each server one at a time. So once you have the one OVA loaded, it's literally one download for every feature and functionality of many servers throughout here. Taz, I see your note there on some links.
Chris, we got a couple more.
Sure, go ahead.
Nope, you're answering it for me, Chris.
Sure. So Taz, I see your note there. What I'm going to do after I stop sharing my screen, I'll put a couple good extra follow-up links per Taz's question. I'll put those in chat for others to share.
Okay, good.
I'll do that after I stop sharing.
One more question, Chris, is can logs of ISE be forwarded to a central logging system?
Yeah, great question. Definite, yes. However, keep in mind that ISE itself can actually have a dedicated role just for monitoring. So you could have a whole 2 or 1 different servers just for monitoring. Or I could monitor on the main server, or I could monitor and connect with Radius on the same server, or spread out the load. So it can be done, but doesn't need to be done because you could have dedicated servers for that. Side note, if you have dedicated servers for monitoring, they need the largest amount of hard drive space because logging is going to take way more hard drive utilization than perhaps the individual server. But back to your question, if I wanted to take the logs and send them to a syslog server, another SNMP server, oh, sure, you can for sure. ICE is not requiring to do it, but we could say that ICE is a fully functional, fault tolerant, load balanced, built-in logging tool. There are some very detailed logs built right into ICE. So you can do it, but it's quite impressive, the detailed logs inside of it. Example, you could do logs both real time and saved over time. So I could see what happened 2 months ago, or I could see what happens right now when this user is trying to connect in. And if there's a password mismatch, all that will show up right in the live logs, or again, I could look months before and see it in the saved logs. All right, team, great questions. Any
That
other?
looks like we have all the open questions, Chris. And let's jump to the next slide if we could. And we still have your outstanding. You're going to add a couple of links there, but I just wanted to let everybody know that we have a course called Cisco SISE or SIS that Global Knowledge provides as a Platinum Learning Partner, and it's actually our second most popular class for attendance, just second to the number 1, which is our CCNA Bootcamp. And Chris, I just wonder if you got any comments on that SIS, anything, it does have 7 modules. It has 21 labs in it. Anything from an instructor level that you might want to add in?
Sure. First, just to clarify, the first letter S here in the course name is for security. So this class is all part of the security track. This is one also course, exam, and elective for CCNP security, if you choose that certification path. So after the security core and this class and exam called SISE, that is for the CCNP security. So the whole class is all focused around the identity service engine and very much hands-on, and all the details we've done here, but in a full 5-day format, whereas here we're doing the 45-minute format. But for those who seeking formal training on that, this is the official Cisco class. And as Brad mentioned, we do quite a few of these at Global Knowledge. George, a question. Does GK allow you to audit a course once you've taken it? I took last look here, the GK was hard to understand. George, that's a feature you can work out usually with your sales rep. If you wanted to retake it, Brad here is the expert on those and how that works. Brad, if you want to comment on George's question a little further.
Yeah. Quick response, George, is if you take a virtual class with, and we retain them for up to 12 months time, and you can access that through our MyGK portal. Okay. So if you've taken the SISE class, for example, we will store it for 12 months and you can go back and listen to those recordings. Now, granted, you won't have access to the hands-on labs, but you will have the lecture-based part of that delivery. Okay. Okay.
Thanks,
Chris.
Brad.
So I think what we'll do is we do have to watch our time. If you want to add yep, go ahead, Chris. Just let you know, just closing off here, we do have some promos. Enter in those promo codes when you're on our website and you're checking out. Next slide, Chris. And if you want to follow us on your favorite social media applications, or you can just follow us on Twitter, Facebook, Instagram, and LinkedIn. And Next slide, Chris. And of course, you can follow us or go to our website, globalknowledge.com, and you can actually do a search for Cisco training on there, or type in SISE and go right to that particular class. We do offer a range of other products and vendor training.